Hi guys, I've analyzed the survey results and it seems that most of you would like to see game development aspects. And today we're going to do basic game development maths. So basically what you need to know about mathematics in games programming. This should get you through about 25% of games programming maths in year one, I suppose. Um, I don't expect you to code in this tutorial. This is more of a demonstration, and just try to focus on the examples. You can, however, code and follow the coding basically, because I will be coding as we go along. So I've just created a file which contains, which is a basic JavaFX application, and it only has these two helper classes, which I will explain in a minute. And yeah, so basically that's it, just an empty screen with size 800 by 600. So some people, when hear game development, immediately think maths. But it doesn't mean that maths has to be complicated in this case. And in 2D, in fact, it isn't. Most of the stuff is really there in the framework that you're using. And if it's a decent framework, then you'll have all the methods you want, pretty much. And it also applies to any languages, to any frameworks you might use related to graphics or game engine or game libraries. And probably the most important thing is to understand why you're using maths rather than how to use the maths. Because most of the formulae will be given to you. You don't need to know how to calculate an area for a rectangle, for example. You'll just call a method called compute area or something like that. And you just need to know what you need it for. And so, for example, if you're using rectangle area, in real-time strategy games, you could calculate the area that you've explored and then divide by the area, sort of the total area of the world, and multiply the ratio by 100, so you get the percentage of the map that you've covered. And this could be a quest to like cover more than 75% of the map or something like that. Alright, so for this tutorial we're going to cover the two most important data structures, which are point and vector. And these are things that you will see in pretty much any game development tutorial, because they are used everywhere in 2D and 3D. Most of the stuff you learn for 2D will also apply to 3D, so you don't have to relearn stuff, which is good. Now, the point and vector in JavaFX are represented by a point 2D class. Both of those data structures are represented by a single class called point 2D. It is not a node, it is pure data structure. So in order to display it on the screen, you need to wrap it with something. And in this case, I used circle class as the base class, and then just created a point view which extends circle. And what we do is create a circle with radius 5, which will be a point on the screen. And we then set translate x and y to this point x and y. So it basically will show this point on the screen. And getPoint creates a new point, and getTranslateX, getTranslateY. Should be pretty straightforward. Now, there is a difference between point and vector, although they are represented by the same class. Point is a position on the screen. A vector is not. It is a displacement or like a line segment with a direction, although they both have the same sort of x and y values. X and y for point would be a position in x and y coordinate. For a vector, that is sort of the positional difference between 2 points. So if I create those things, it'll be easier to display on screen rather than to talk about them. So we have point view, point 1, or let's call it player, new point view. It also takes a point 2D, and we'll place it, we'll place our player at 100 and 100. It is also important to note that in JavaFX and in many other graphical user interface frameworks, the origin, the 0, 0 coordinate, is in the top left corner, not bottom left, like you're used to in mathematics. Yeah, so we've created our point view, and we now need to add it to the scene graph in order to show it on the screen. Here we go. We got our point, and it is at 100 and 100, so in x direction and in y direction. Positive y-axis goes down, and this is something you need to remember if you come from a mathematical background. If you have a programming background, then you're pretty much used to it, so don't worry. Now let's create another point, which is enemy, and we'll place it slightly to the right, so 100 and let's say 250 and 75. We also need to add it to the root. So now we've got 2 points, our player and enemy. Now we can, so basically you use a point to position your game objects. And this position will be translated, and the word translate, or rather the term, means to sort of move an object in x and y using the vector. So you use vector to move things, and you use point to place things. And all of this stuff will be done against the origin, which is 0, 0, which is right here. And this allows you to keep track of your objects within the game world. This also applies for 3D. Alright, so we can now create a vector view. Which also takes a point 2D, although now it represents a vector. So what we can do is we can obtain vector from one point to another. So this will show the actual translation from one point to another. Our enemy is to the right, so we'll use enemy first. Get point, subtract, player, get point. So this is pretty much mathematical definition of a vector. The difference between 2 points. It's probably the most simple definition you can get for a vector. We also need to move the vector to our player point, so it goes from there. Yeah. So now we have our vector, which is this line segment, and it also has a direction, and this direction is to the right because we've done this minus that. So we got the point for our enemy, and we subtracted our player's position, and we got a vector. However, vector does not have any positional properties. So if we don't do that, so if we don't move it, it will be drawn from 0, 0, so to the top. It will actually go off screen. And if we want to move it to the place where we can actually see it, we can do, yeah, that'll do. So we're actually moving it to 0600, which is the paper origin. Sort of when you have your y-axis going up rather than down. So this is actually the same vector. It has exactly the same properties as the vector that was drawn between 2 points. And if we move it to this, or rather we draw it from this position, this will describe the sort of the positional difference between 2 points. Now, why do we need all this stuff? It is very useful for pretty much everything you want to do in games programming. One of the examples could be if your enemy is shooting your player. It's a very simple AI that shoots your player every certain amount of time. So let's create a mouse click handler so we can manually position our point. Let's move all this to the outside. So whenever we click on the scene, we'd like to move our player to that position. So we'll set translate X to event get scene X. Now we've moved the player. We'll also need to recalculate the vector. So vector, if you remember, this is the actual data structure. This is not something, this is not a UI element. And we can do this by doing that again. So we obtain point for our enemy, or where our enemy is. And now that we've translated our player, we can also get his new point. And by subtracting one from the other, we obtain a vector from one point to another. Finally, we will need to set the vector, which calls this method, and it simply changes and X and Y. And vector view, I used line as the base class for vector view, which is convenient because it is really just a line segment. Now we probably need to move this yeah, actually let's just run. Yeah, it draws the vector, but not from the point where our player is. So if we change this to enemy, it will draw from the enemy, which is also not something that we need to have, because we're doing the opposite. We need to get a translation from player to our enemy rather than from enemy to player. So it's basically the reverse. and this is now the correct correct direction. It's a shame we cannot really draw arrows. That would be much easier to see. So now we're moving the player, and we're also calculating, so we're subtracting enemy's position from the player's position to get this vector from one point to the other. And this is how you can obtain vector to aim at the player. But this vector, or the magnitude, so the length basically of the vector, is not is very large for just one tick. Your bullet will immediately get from your enemy to your player. And we can sort of shorten the length of the vector by simply calling normalize on it. And calling normalize will reduce the size or length of the vector to length 1. And we won't actually see it on the screen because it's too small. Yeah, it points correctly, but it is very small and we cannot really see it. What we can do is multiply by certain factor, and this factor is really the speed of, or the speed at which you want your bullet or projectile to travel every tick of the engine, game engine, or whatever engine you're using. So if we say 15, so this is the length of our vector now. It will point at the player all the time, and this is the length that will be added to the position of your bullet every time you shoot at the, basically every tick. Now we can actually animate this. So if we create a translate transition, with duration of 3 seconds, we need to import this first, and we're translating we could translate an enemy if we want to, but let's create a new object. Point view, let's call it a bullet. And this starts where the enemy is, so we get point of our enemy. And this is the object that we're animating. So there are 2 ways of setting how the object will be animated using translate transition. You'll either set by x or 2x, and the same for y value. Now setting 2x and to y would be using player's position, and this time we'll be using vector x and y magnitudes to demonstrate the whole vector thingy. Now we can actually set it to auto reverse and set cycle count 2, so it goes from one point to the other and then comes back. also need to add the object to the root of our scene graph, so it's displayed on the screen. And when the animation finishes, we want the object to be removed from the screen. Yeah, now that we've set by x, it actually gets the x and y, and then it moves to this length and then goes back. Now if we remove that part, so we get the actual full length vector, it will now move the full length and then go back. So this is how you can, without hard coding, dynamically find the direction or the aim for your enemy's bullet when he's shooting at the player, and then set that vector as the velocity of your bullet. So yeah, that's pretty much it, I think. So we've covered the point and we've covered the vector. So the most important thing to realize is that point is a position and vector is a displacement. So in order to obtain a vector from point 1 to point 2, you need to subtract point 1 from point 2. And if you remember, when we did it the other way around, when we subtracted the other point, we actually created the sort of negative. It was exactly the same, it had exactly the same length, but it had a different negative direction to what it should have been. And apart from that, I think this will be it for the basic mathematics, and this stuff also applies to 3D. The only thing that is different is the z-axis. So if you get all of this stuff for 2D, it'll be much easier to understand this in 3D. And yeah, so thanks for watching.